Hello everyone. In this video, I'm going to explain the solutions to the polynomial practice problems. If you haven't already, please make sure to watch Class 1 Polynomials video, as all the basics of polynomials, along with many example problems were covered. In addition, I highly encourage you all to try these problems before watching their solutions. Let's start with this problem. Find the sum of the reciprocals of the roots of x squared minus 13x plus 4 equals 0. So what is the sum of the reciprocal of the roots? Well, if the roots are r and s, the sum of their reciprocals is just 1 over r plus 1 over s. Because remember, the reciprocal of a number is 1 over that number. So 1 over r plus 1 over s is the sum of the reciprocals. Okay, so if 1 over r plus 1 over s is the sum of the reciprocals, how can we find out this quantity? So generally, we want to use Vieta's formula whenever we don't want to find the exact value of the roots, but we want to find some expression in terms of the root. So some expression in terms of the roots is 1 over r plus 1 over s. So when we simplify this, we get equal to s over rs plus r over rs, which is equal to r plus s over rs. And what is this equal to? Well, these expressions we can easily find by Vieta's formulas. So r plus s by Vieta's is negative of negative 13 by 1, because the sum of the coefficients of a quadratic, sum of the roots of a quadratic is just negative of the x term by the x squared term. So this is 13. The product is rs, which is going to be equal to, remember, the coefficient of the constant term divided by the coefficient of the x squared term, which is 4 divided by 1, or 4. So then what is r plus s over rs? It's just going to be equal to 13 divided by 4, because the sum is 13 and the product is 4. And this is 13 over 4, which is the sum of the reciprocals of the roots. And that's it for number 1. Now let's take a look at number 2. And this problem, we intertwinkle some number theory in as well. So for this problem, the idea is that we want to have two roots of this quadratic be prime numbers. So two roots of the quadratic, let's say, are r and s, and they sum to 63. Okay, so let's just say that we have two roots, they sum to 63, and they're both prime numbers. And then, so what does that mean? Well, we have two roots that are prime numbers, so r and s are both prime numbers, and they have an odd sum. And if you remember from the AMC 8 and AMC 8 class that I did earlier, you can check out the video for that if you haven't already seen it. We covered that in order for two numbers to have an odd sum, that one of them has to be odd and one of them has to be even. So since we have an odd number sum here, one of these r and s has to be odd and one of them has to be even. But we also know that both of these numbers are prime numbers, meaning that the even root of the quadratic has to be 2, since 2 is the only even prime number. So since 2 is the only even prime number, then we know that this s, the even root, has to be 2. And that means the other root has to be 61. Because 61 is the other root in order for the total sum to be 63. And we can indeed verify that 61 is prime. So therefore, the only possible two roots of this quadratic are 61 and 2. Because only then will we have an odd sum of two primes. Okay, so if the two roots are 61 and 2, then what will be the product of their roots? Then their product of the roots will just be rs, or 2 times 61, which is equal to 122. So overall, there's only one possibility of value of k, possible value of k. And that's the answer for this problem. And now we're done with another problem. This one is interesting. The sum of two fractions is 11 over 12, and their product is 1/6. What is the lesser of the two fractions? You might be asking, why is this in the quadratics, polynomials, Vieta's chapter? The interesting part of this problem is we can actually make it from what seems to be a guess and check problem into a problem with Vieta's and quadratic formula. Let me show you how. Let's say we have two fractions, a and b. So a and b are just two fractions, and they have a sum of 11/12, like the problem says. And their product, ab, is 1/6, right? Now, well, if a plus b is 11/12, if ab is 1/6, then we can form a quadratic, right? Because if the sum of two fractions is 11/12 and the product of two fractions is 1/6, what will be the quadratic with the roots of a and b? So just imagine a quadratic with two roots, a and b. A quadratic that has two roots a and b will be of the form x squared minus 11 12x plus 1 6 equals 0. A and b will be the roots of this quadratic. The reason is we know that a plus b by Vieta's formula from this quadratic, a plus b is equal to negative 11 twelfths divided by 1, which is 11 twelfths. And the product of roots from this quadratic is ab equal to just 1/6 divided by 1, or 1/6. So we know that the two roots of this quadratic will sum to 11 over 12 and 1 over 6. And we want to find the lesser of the two fractions. So now what we can do is I'm going to erase this just to make up some more space. So now what we're going to do here is that with this quadratic we have here, we can just solve for both of the roots using the quadratic formula. Just to summarize the steps in case you find it confusing, we know the sum of the two roots is 11 12th, product is 1/6. So a and b, the two fractions, will be roots of this new quadratic. And we'll have a sum of 11 twelfths and a product of 1/6. And then we can use the quadratic formula to get negative b plus minus the square root of b squared. So 11 over 12 squared minus 4ac minus 4 times 1/6 times 1 over 2, and 2a, or just a, just 1. So I'm just applying the quadratic formula here. Pretty simple application. Equal to, well, let me just move here a little bit. So it's going to be equal to 11 twelfths, of course, plus or minus square root of 121 over 144 minus 4/6. But 4/6 is just equal to, well, we can multiply the numerator and denominator by 24 to get that 4/6 is just 96 over 44, or 144. We just converted it to one denominator, divided by 2 again. And then what we can do is we can simplify this expression in the middle to get 25 over 144. So this is just 25 over 144 in the middle here. And then we can solve this, we can simplify this to get that this will be just 5 twelfths. This expression will just be 5 twelfths. And then, as you can see here, the two roots will just be 16 over 12 divided by 2, and 11 twelfths minus 5 twelfths, or 6 over 12 divided by 2. And then the simplify to 2/3, this is equal to one of the roots is going to be 2/3, and the other root is going to be equal to 6/12 divided by 2, or 1/4. So the two fractions that work are 2/3 and 1/4, and those are the two roots of our quadratic, and thus those two roots have a sum of 11 twelfths and a product of 1/6. So the lesser of the two fractions is just 1/4. And we're done again. And the clever idea here is that we converted what seems to be far from related to quadratics to an easy Vieta's problem and quadratic formula problem. So hopefully my explanation was clear on that. Okay, now let's take a look at the next problem. Suppose a and b are non-zero real numbers such that the equation x squared plus ax plus b has solutions a and b. Find the ordered by a, b. That seems interesting. So we have a quadratic that has two roots a and b, meaning that we have a plus b, the sum of the roots, or solutions, is equal to negative of a divided by 1 by Vieta's. And the product of the two solutions, a, b, is b over 1 by Vieta's, or b. This is just negative a. So now what we can do is we can actually see that, oh, ab is equal to b. And since a and b are non-zero, we can divide by b to both sides. Because as long as b is not 0, we can divide by b to both sides. If b was 0, well then we cannot divide by 0, because that would be undefined. So now we know that b is not 0, so we can divide by b to both sides to get that a equal to 1. And then we can substitute it back into our first equation to get that this is going to be equal to 1 plus b equal to 1, 1 plus b equal to negative 1. Meaning b is negative 1 minus 1, or negative 2. So the ordered pair is just going to be a equal to 1 and b equal to negative 2, and that's the answer. And we're done with yet another problem. And this is another problem that we just essentially converted it to a easy problem using Vieta's. Next problem. Ooh, this one was interesting. In this large, ginormous polynomial, the product of two roots is negative 32. Find k. Okay. So in this large polynomial, what we can do is we can actually write it as Vieta's formula again. Let's say our roots are r. Let's just have to say a, b, c, and d because that's easier to work with. A, b, c, and d. So we have that a plus b plus c plus d is 18. We have ab plus ac plus b, or let me write it in a more structured manner. AC plus AB plus AC plus AD plus BC plus BD plus CD is K by Vietas. Because the sum of the roots is just going to be negative of negative 18 divided by 1, which is 18. And the sum of the pairwise products is going to be K divided by 1, or just K. And the sum of the products of 3 roots is going to be ABC plus ABD plus ACD plus BCD, which is going to be equal to, well, negative, or I should have just written in the beginning, negative, positive, negative, positive, like I taught in the class. So negative, positive, negative, positive. So this is going to be negative. So negative of 200, because it's just going to be negative of 200 divided by 1, or 200. And if you remember from the previous class, we always alternate in signs. And the final thing is we have A, B, C, D is negative 1984. And net positive of that. So negative 1984 by 1, which is just negative 1984. So now what can we do? Well, we also know that the product of 2 of the roots is negative 32. So let's just assume that AB is negative 32. The product of the 2 roots, AB, is negative 32. We don't know which 2 roots they are, but if you think about it, we can just assume that those 2 roots are A and B. Because it doesn't matter whether we say that AB is negative 32, or if you say that AC or BD or whatever is negative 32. So we can just assume without loss of generality that AB is negative 32. Because it doesn't really matter which 2 roots we choose to have a product of negative 32. Because all the roots are really the same. The variables don't really matter. That's why I'm just saying that, okay, let's say that AB is negative 32. Because 2 of the roots, any 2 of the roots, can be negative 32. And we can just designate those 2 roots to have a product of negative 32 to be A and B. Okay, so then you can say that, okay, ABCD is negative 1984, and AB is negative 32, meaning that negative 32 times CD is negative 1984. We divide by negative 2 to both sides, negative 32 to both sides to get CD is 62. Okay, so CD is 62 and AB is negative 32. Now what can we do? Well, we can substitute it back into our expression for CD and AB. So if we substitute it back into our expression, so I'm just going to copy this really, really quickly. So let me just take that here, copy it, and paste it here. So I just pasted it there. Okay. So we can substitute it in. We know AB is negative 32, so we have negative 32, the value of AB, plus AC, plus AD, plus BC, plus BD. So, and what we notice about these terms, and plus, sorry for the confusing explanation. So plus AC, plus AD, plus BC, plus BD, plus CD, which is 62, equal to K. We simplify this to get 30. We can combine these 2 terms to get 30. Plus AC, plus AD, plus BC, plus BD, equals K. So what do you notice about this expression right here? What is this expression really? This expression is just equal to, well, we can simplify it to get 30 plus A plus B times C plus D. Because if you think about it, we're just multiplying A times C, we're multiplying A times D, we're multiplying B times D, and then we're also multiplying B times D. So we're getting all 4 terms that we need from this expression is K. So we're just multiplying these 2 expressions to get all 4 of the other terms that we didn't already have. And the reason we think of doing that is because we know a lot about A plus B. We know a lot about sums, right? We know a lot about sums. So we think of making it into an expression that somehow deals with sums. So if you make it into A plus B times C plus D, we can do that. And just to see, the reason I did that is because we have A common. We have A common amongst these 2 terms. A common amongst these 2 terms. And then we have B common amongst these 2 terms. So we just group it into A times, let me just make my explanation a little bit better here. We just group it into a times c plus d, because we have a common from these two terms, plus b times c plus d is k, and this becomes just a plus b times c plus d. So we can just simplify that to get 30 plus a plus b times c plus d is k. Okay, so now we know that a plus b plus c plus d is 18. So we can substitute it back in. This will just be 30 plus a plus b. But we know that c plus d, so since we know that this expression is true, we also know that c plus d will just be equal to c plus d. It's just going to be equal to 18 minus a plus b. Because we know a plus b plus c plus d is 18. So we can also subtract a plus d from both sides to get that c plus d is just going to be equal to 18 minus c plus d, a plus b. So this is going to be 18 minus a plus b equal to k. So we can just subtract a plus b to both sides to get that expression. Now what? Well, now what we can do is we can see that, okay, we really just need to know the value of a plus b, because we want to find k. What is the k? So we can just, if we can find a plus b, then we can find k. So how can we find a plus b? What can we do? So generally, whenever you're dealing with some complicated problems or even simple problems, sorry if my head was blocking that. So if you're dealing with complicated problems or even simpler problems, the idea generally is to look for the information you have not used yet. So the information we have not used yet is this fact here. We've not used this fact yet. So what does this really tell us? Again, we're going to have to find a plus b somehow. So we can find a plus b somehow. How can we do that? What do we notice in this expression? So really, this is the only expression we haven't used yet. This one here. So how can we even use this information? So generally, whenever you have information you haven't used yet and you're stuck, somehow try to use that information. So what I'm noticing right here is that we have b common from these expressions. And what I'm also noticing, what you can also notice is that we have ac common from these, we have cd common from these expressions. So if you have ab common from these expressions and cd common from this expression, we can factor it. So I'm going to just paste it. So this expression that I have, we can factor it into ab times c plus d plus a cd, we can factor out cd from this expression, cd times a plus b. Nice. So now we know the exact values of ab and cd. We know ab is negative 32. We know cd is 62. So we plug them into the expression, we get negative 32 times c plus d plus 62 times a plus b is negative 200. And then again, from earlier, we know that c plus d is just 18 minus a plus b, because from this first equation here. From this first equation, we know c plus d is nothing but 18 minus a plus b. So negative 32 times 18 minus a plus b plus 62 times a plus b is negative 200. Nice. So now now let's just find a plus b from this equation. Because now we know that the only really thing we have to find is just a plus b. So now from this equation, we can easily find the value of a plus b. So let's just expand that out really quickly. Negative 32 times 18 is going to be negative 576. So this will be negative 576 minus 32 times a plus b plus 62 times a plus b, where I'm just expanding this whole thing out. And then I simplify this even more to get negative 576 plus 32 times a plus b plus 62 times a plus b, which is 94 times a plus b. Is negative 200. And then what we do is we add 576 to both sides. So we add 576 to both sides to get 94 a plus b is 376, because 576 minus 200 is 376. So when we add 576 to both sides, this negative 576 disappears, and this becomes 376. And then we divide by 94 from both sides to get a plus b equals 4, since we know that 4 times 94 is just 376. Okay, so now we know the value of a plus b, and that's really good for us, because then we can substitute it back into our expression to get the value of k. And that means that k is just 30 plus a plus b, which we found to be 4, so 4 times 18 minus a plus b, so 18 minus 4, or 14, is equal to 30 plus 56, or 86. And so we know the value of k is just 86. And that's the answer for this long problem. And this problem was actually from the USAMO 1984, except what's funny is that this was a number 1 on the USAMO from a long time ago. So nowadays, the contests become a lot harder. So you won't find anything like this on the USAMO or USAMO these days. Okay, so thank you for watching this video. I hope you learned something or found these problems interesting and great practice for polynomials. And again, like I said earlier, polynomials are really important for the AMC 10. It's really crucial that we master this concept, because when it comes in the exam, then you can easily do them. That's the great part about polynomials. Thank you for watching.